All right. Welcome back to Map 23. And again, this chapter, it's really complicated. Again, chapter 5 is a harder chapter, and it's usually takes really our, you know, very important process to get through. And the material that we have here, I uploaded the chapter. So let me just point it out real quick. And this is a thing. And we already have 5 different chapters uploaded in Blackboard. I'm basically going to go over all of that. And so there will be homework chapter homework 4 due today. Make sure that we're gonna upload it the work. So when you look at the assessment, we're going to have to click on homework. So it's right there. So it will be due uh, today. I'll make sure that we're gonna submit it. I'm gonna make homework 1 unavailable, homework 2 unavailable, and homework 3 unavailable. So I'm gonna agree all of that. And homework 4 will also be unavailable. So we're not able to submit them. So yeah, homework 4 you do today. I will basically close this today. So when we come back on tomorrow. So tomorrow we're having another class. We know the fact that today is going to follow Monday's schedule. And so tomorrow going to be the normal day that we have another class. And we're going to finish chapter 5. So I have planned out the exam review, but I didn't really have time to upload it. There's a thing around 37 questions. So we try to go over as many questions as possible for this part. I feel like it's really important. Okay. So the homework review I categorize. So let's say chapter 2, chapter 3, chapter 4, and chapter 5. So each chapter they have a number of questions. You don't necessarily have to do all of them, as long as we can understand and know where the question is coming from, and it should be all right. So again, that the exam 1 review will be uploaded in Blackboard, and that's really important that we follow through the exam review. So right after we finish chapter 5, so it's impossible to finish chapter 5 because of the fact that it's really a long chapter. So let me just go back to chapter 5 that we have right there. So we finished the first part. We can't finish chapter 5 for after the exam, so we're still in the we're gonna study another part and leave it for a second exam. So chapter 5 is this really long chapter. So we got you to the homework 4 is due today, so make sure they're gonna complete them and submit work on Blackboard. So you cannot submit them after today, and make sure that we're gonna do it. Homework 5 will be due next Tuesday, next Monday. Okay, so after homework 5, there will be homework 6, and then after homework 6, we're gonna have the first quiz. So there will be another quiz on Monday. Make sure that we're gonna attend them. So after that, we're gonna have the exams review and the exams on Blackboard. Okay, so usually let me just tell you what the exam looks like. The exam will be around 6 to 7 questions, and we have 2 hours to complete them. Okay. Yes, for all classes. So there's no class because yesterday was the Yom Kippur. It's actually a Jewish holiday, so we have no class. It's resumed today, and tomorrow we have class as well. Yep. Questions, Ulysses?
Hey, Professor.
Yeah.
Yeah, I'm asking if you had, let's say you missed a homework assignment, is it too late to turn it in?
Which homework did you miss?
The last one.
The homework 3?
Yes, sir.
Okay, so just email me and tell me the reason why you missed. I will accept that for the homework. Make sure that you submit it on Blackboard.
All right.
Okay.
Thank you.
Yeah, you're very welcome. So, any other concern? Any concern that you have? Any other questions for that? So again, the exam will be uh 2 hours. So right after we finish the exam one review, which is pretty much on Monday, and then we're gonna have the exam on Wednesday. So we have 2 hours to complete them. You're gonna have the whole day to complete it. Um, Starting from 6 a.m. in the morning until 11:59 p.m. So if you plan to work on Wednesday, like next Wednesday, you can't tell me that I work more than 15 hours. So you must have a certain time that you are available to do the exam on Blackboard. Okay, so when you start it, you have to finish it. Each person gonna have different questions, different combinations. Um, so you can't really like uh, two people cannot have the same question generally. I will let you know how we're gonna proceed that later on. Okay, so so now we're gonna go to a very very difficult part. That's actually the somewhat, I would say, the most challenging topic that we have in probability. I'm not trying to like ask you to master those skills, like probability reading problems or certain concept, but it's really really important that we understand certain keyword. Uh, so one of the keyword that we need to understand would be this letter. If you ask me what is this one, I don't know. It's small. It looks like a letter U, but it's one of the Greek letter. It's represent. It's not like letter U. It's similar to letter U, but it's one of the Greek. It's not the ancient Greek. It's like a most recent Greek letter has been used for a certain subset, and so on and so forth. So that's really really important. So so this basically means the union. So this is what it means. The keyword for that is or. Okay, so the or represent the union. Um, so the reason why we call this is union, I don't know. It has been using for so long, and I have no idea why people use the keyword union. So it's more like the letter U for that. No, all right. Okay, so that's perfectly okay. So let me just repeat that again. So this letter U represents the union, meaning that we're going to take or uh, all the numbers, all members between sets, okay? All member between A and B, for instance. So we have two sets. So this is what we have. Right? So make sure that we're gonna mute the microphone when you yes questions. Yeah. So so this is really 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 important. So you represent the union, so meaning that we take all the common member, all the members without overlapping. Okay. So we cannot take something twice. It's really really important. Okay, without overlapping sets, overlapping members. So this is really really important. So I'm going to point it out and highlight them and making sure that we are understanding what it is. So we can't have the more than one members. I'm sorry, we cannot have something that repeated twice. So this is another word for this. And another keyword that we need to understand would be this letter, and it's represent the intersections. So this is something that we call intersections or the join. In other words, the keyword for that is and. It's more like an upside down U, and the keyword for that is and. It's very very important. So we need to box this. This is the keyword. So this is what it means by join or taking the intersections. Um, However, the keyword for that represent these. I'm gonna highlight box them. This is really really important. Those are the keywords that you see on the exam. So the join and intersection meaning that we're going to take all the common members
between A and B. Okay, all common member. All common member. All A and B have in common. In other words, member that A and B have in common. Okay, so it's really important that we keep that in mind. So the member that they have in common. Okay, so I'm gonna give one example and elaborate on a process. Usually it won't take that long to do so. And the example that I'm going to give you will be, let's say we consider two set. A will be 1, 2, 3, 4, and 5, okay? And then apparently that we can have the set B. So there will be another things, will be 4, 5, 7, 8, and 9. So for instance, so all of this are really something that we can have them. So if we want to do A and union with B, so meaning that we're going to take A or B, okay? In other words, usually I'm going to say, I'm going to call this as A or B, okay? So either way is fine. So for those of you who are not able to understand two Greek letters, then we can't just use the keyword or, and I will understand that while we're taking the union set between A and B. Okay, so if you can't use this letter, one of the Greek letter, that would be great. If we can't not do it, we just use the keyword or. I'm gonna change that to using different marker so that we can know what it is. So A and B that we can have. So we're going to taking a joint member. So that we're going to take all A and all B members in this case. So we're going to take 1, 2, 3, 4, and 5. So again, we do not allow overlap members for the union. So we do not count 4 and 5 twice. In other words, we're going to take 7, 8, and 9. So if we count 4 and 5 from set B, meaning that is repeated twice, which is not correct. So making sure that we only count it once. Okay. So this is what it means by taking the union. I take all the members from A and to B. I take all of them, except for the fact that if they have the common members, we only count once. We do not count twice when we take the unions. So on the other hand, when we're doing the A intersects B. So I'm going to change the marker a little bit, intersects B, right? So in this case, instead of we taking the union, so now we're going to take the joint between two sets. So we'll take A and B, okay, and B. So the keyword for the joint would be and that's really important that we're going to do so. So meaning that we're going to take the common members between A and B. So we can literally check there are two common members, 4 and 5, and then just put them down as 4 and 5 on a list. So this is what it means by the join. This is what it means by the intersection. Okay, so A and B will be 4 and 5. In other words, we go into establish the formulas between this or that. So what happening for this is I can't actually establish this formula so we can have A or B, right? We're taking the number of members, and we can literally check that I can take the set 8, which is 1, 2, 3, 4, 5, and I'm going to add the B in this case, so that'll be 4, 5, 6. I'm sorry, there's no 6, 7, 8, and 9, right? So when we add them up, what's happening? When we add them up, we're going to count 4 and 5 twice because it's repeated, right? So those are the common members between two sets. So in order to get rid of that, we need to take away, we call subtract, okay? We take away the members from the common set. So that'll be 4 and 5 in this case. And then we're going to get the union, which is 1, 2, 3, 4, 5, 7, 8, and 9. All right. In other words, when you combine A and B, if they have the common members, we always have to take away the join to get the union set. So this is really, really important. So let me just repeat that again. A or B in this case. So this one will be A, right? Apparently that one is A. This one is A. And then that one is B for sure. This one a number of B, we have 5 of them. And then we take away, this one is A and B. Okay, A and B. So let me just repeat, let me just rewrite them a lot better. A and B. Okay, and then when we subtract them, we're going to get A or B. Okay, but all of that was in terms of the members. So let's say we call N will be the number of the units. So in this case, we're going to let the number A or B. So will be equal to the number of A equal to the number of B plus the number of B. Again, when we add them up, is always something that we left out with the common set, with a common member repeated twice. Then we have to take away the join. We take away the A and B. So that's really, really important that we understand this strategy, because when it comes to the probability, it worked pretty much the same thing. So when it comes to the probability, so instead of using the n will be how many numbers that we can count them. So you can count 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to take 5 of them plus 5 of the B and take away 2 of the join. I'm going to get 8 of them. So it's going to be the same thing that work out for the probability, and that will be probability of A or B. In fact, I'm using the keyword or. If we're not used to it, we can use the keyword or, equal to the probability of A plus the B. And then after we add them up, then we have to subtract them, because when you add up like that, we just add the middle probability twice, which is the joint between A and B. Then, so the whole point of doing so is to make sure that there's no common probability that we add twice. Then we need to subtract them. So that'll be subtract A and B. Okay, so I believe this is a very important formula that we're going to keep them until the final exams. Okay, so I want to box this. All right. Okay, doesn't seem to be. All right. So in other words, what happening for that is we going to, so whenever I see the keyword or, so the keyword or, the probability of the or will be the probability of, you just add up too big, we need to add of too big and subtract the smallest, because the joint always be the smallest values and subtract the smallest. Okay, and this is a thing that we need to know on the exams. Again, there will be some repeated probability that we need to add them up. So the A and B always be the biggest set in this case, and then the A and B always be the smallest, because that will be the joint between A and B. And so this is a thing that we need to pay attention to. All right, so but how can we utilize that to solve for a certain work problems? Then we're gonna see some question like that. So so let's say we're gonna go to question number 4, and then I'm going to deal with that questions. Okay, so so let's go for it. I'm gonna copy and paste. Just want to make sure that we can finish it fast. Okay. So question number 4 that we have right there from the notes, so we can double check that. So this one is the question. So the employee in the store are 63%, 62%, and they were 45% part-timers and 33% female part-timers. And what is the probability that a random selected employee is a female or part-timer? So we're gonna highlight a keyword. The keyword is really, really important. So we highlight that. So this is the or, right? And we're going to look at the probability of female. In this case, that will be 62%. And the probability of part-time, so that will be 45%. And we also have the probability of the female and part-time, so that will be and we're going to have this one is 33%. So what's going on for that is we need to figure out the keyword or. So in other words, we need to look for the probability of female or the part-time. So that basically that one is the keyword for that is or. We're gonna look through it. So whenever it comes to the keyword is or, then we're gonna take the probability of female plus the probability of part-time, and then we subtract the and. So that really, really important, okay? So in this case that we're going to take 62% plus 45%. And then we subtract 33%. That's pretty much the thing that we need to do. And on a calculator that we can literally check it, make sure that we're not gonna do it by hand. We have to do it on a calculator. So for this part of questions that we need to use, just add up the two big and subtract the small values, and then you're gonna get this, and we're going to get these answers correctly. Let me just wait for my calculator to zoom, and this is how it goes. What do you get? Well, it's absolutely, when we draw the Venn diagram, then it's going to be able, we're going to understand what it is. But we're going to do the work first and see what it is. So 62% plus 45 minus 33, and we got the answer, which is 74%. So first step that we need to understand is whenever I see the keyword or on the exams and on finance, and this is the easiest questions. So what we need to do, we're going to add up the two big numbers so we can literally watch them. So 62% will be the probability of female, and 45% will be probability of part-timers. So we're going to add them up. So when we add them up, what's happening? We're going to add up the common sets twice, the common probability twice. So we need to just take away 33%, which is the middle, which is the joint probability between the female and part-timers. And after that, we're gonna get 74%. Okay, so we just add up a two big number, and then we subtract the smallest values. So in order to understand it, I'm gonna do another example, and then I'm gonna draw a Venn diagram to explain it. But please try not to make the class complicated, but just try to follow certain rules that we have for the probabilities. So when it comes to the keyword or, we highlight them, just add up two big and subtract the smallest. So let's try them out with some of the multiplications problem, and you will see what it is. So I want to pick the questions like this. Okay, I want to pick the questions with joint. So let me just do that. So this is question number 4. And I will let you know what it is, okay? So this is what the question looks like. This is, so first we need to realize the keyword in this case is or, okay? Is or. So we're going to highlight a keyword for that particular questions. So the keyword is or right there. And after that, whenever you see the keyword or, what we need to do is that we need to look at what we need to figure out the probability of we need to write them down. The probability of retire is 30%, and the probability of male is 18%, right? And then the 52%, I apologize, and the probability of the retire and males, men will be and. So this is the keyword and. We have 18%. Okay. So according to what we learned, the probability of the or, we're going to use the same marker. The probability of the retire or male in this case. So will be, so we're going to take that or equal to, we're going to add up two big numbers. So the two big numbers that we can see from this question is 30% and 52%. And then we take away 18%. So doing this on a calculator is going to give us 30 plus 52 minus 18. So the answer for that is 64%. So this will be the final answers. But a lot of you might be asking me, how are we going to get these answers? Should we just like memorize this trick until the final exam?
Wait, can we do that? Can we do that again, Professor, please? I think you're going a little bit too fast.
So what I'm doing is basically when it comes to the or, you just basically follow the rule right there. We add up a two big number, and then we subtract the smallest, right? So can you figure out what are the two big numbers that you have on the questions?
This is going to be on homework 5.
I'm sorry? Yeah.
I said this is going to be on homework 5.
It's actually question number, yeah, it's from the multiplications questions right there. It's actually question number 4 as well, but it's on the multiplication and addition laws problems. Okay, so I need people to identify the two big numbers that you have on the questions, which are okay, so 30% and 52%, correct? So right after we have these two probability, we just add them up. We add these two numbers up, and then we subtract 18%. So 18 will be the smallest values, and then we're gonna get we will be able to answer the question or correctly. Are we good?
Do another one.
But some people said that, well, we don't understand. It makes no sense, right? Anyone who want to know why this is equal to 64%? Okay, let me just draw a Venn diagram real quick for that, and we'll understand what it is. It is actually pretty important as well, but I only do it once because we're not required to do it on the exams. So first, the keyword, I'm going to draw two circles. So one of them will be so this is what we call a Venn diagram. This one is the retire. Okay, retire will be 30% in this case. Okay, so the entire thing will be 30%. Okay, and then we have the male. I'm going to use a different marker for that. So male will be 52%. Okay, so they have a joint. Yeah, the keyword is or. Yeah, whenever it comes to the keyword or, we just add up too big and we subtract the smallest. These questions will always be on the exam. But what's happening for that is, so the joint between two of them will be 18. So this little things will be 18% right there. Okay, this little thing will be 18%. So so that will be 18, no matter what, right? And so we know the entire big one, the entire big green circles that we have will be the number, will be the percent of the people who got retired. So that would be 30%. So so the middle part will be 18. So the rest part of it, so this one will be 18. I'm gonna just pant them with different. So this one is 18, right? So the rest part of it, so this guy will be 12, correct? This one will be 12 because the entire big circle will be 30%. Okay, and then I'm gonna pan with this marker so we can see what it is. So this one is 12 because the total circle that we have is 30%, and the male that we have. So this is what we call the male, right? This is what we call the male. Let me just use for that part, and then we can indicate them. So this one would be the male, right? So the male that we got is 52%, correct? And this one is the retire. All right, so we can literally check the male 52%. We take away 18. We're going to have this one is 34%. So I'm going to box this using different marker so we can literally see what we're doing, right? So this one is 34%. I'm going to put them down right there. So 34%. What is that meant? We're going to box this. Okay, right. So, so what that represents is this is the male, but not retire. The male still working. This one is the male and retire. This one will be a retired female, 12%, right? And it's not going to be like part of the male. And when we add them up, you're going to take 12 plus 18. Let me just do that. 12 plus 18 plus 34. So when I separate them into 3 different boxes so that they do not have to overlapping, when I add them up, so that will be the union. So that will be the retire or male. When we add up these 3 numbers, I'm going to take 12 plus 18 plus 34, and I still get the same thing, which is 64%. Okay, but doing so is a little bit too long because of the fact that we need to isolate them into like 3 different categories, right? So we're going to look for 18 first. So that'll be a joint between the retired and men. And after that, we're going to look for the male but not retired. And then we're going to look for the part, which is the retired but not male. And then we're going to add these up. We got 64%. But doing so is basically too long because we didn't have time on the exam to answer the question like that. So meaning that I'm going to take the sum of 30%, I add with 52%. When I do that, I just add 18% twice. So in order to avoid them, I need to take away 18. I got 64%. Okay, so this is what the reason why we need to add up too big and subtract the smallest. But we're not going to utilize this technicality on the exam because this one is really complicated. All we need to do when it comes to the or, the keyword or, whenever you see the keyword or, all we need to do is just add up too big and then we subtract the smallest. Okay, so similarly, I'm going to pick a question like that. I would say I'm going to pick questions number, let me just check them out. Let me just pick a question. Okay, so this one makes sense, makes more sense for me. So I want to go to another slide. It seems to be a really complicated question, but when we do it, it wouldn't be that bad. All we need to do is just identify the keywords correctly. So for this example, what is the keyword? What is the keyword that we can find from this question? You have to read the question at the end. Whenever
It's
the question
or.
is or, right? So I always pick the or because apparently that we can check them or. So when it comes to the or, what should we do? We're going to add up too big. So the two big number that we can have for the percentage will be 45 and 35%. The smallest have to be 18. So the probability of the females or nursing majors. Well, I mean, I have a lot of nursing, female nursing majors in my class last semester. I mean, like every year, I have no idea, but usually it's happened because nursing is actually the greatest salary in the U.S. career. So we can add them up and subtract 18%, you're going to get the final answers correctly. We could take 45 plus 35 minus 18. You don't have to convert to like 0.45 plus 0.35 and subtract 18 because we just add and subtract the percentage. So we don't really have to. The answer for that is 62%. Okay. Are we good? So the keyword again would be or. We need to highlight that. Okay. Now we're going to go to the next question. Let me pick another question for practice, and then we move to the next one. The and is not good, okay? And will be a different concept. Or is just the question that we did. So let's do question number 9 from multiplications and addition laws for that. This is what we call additions, okay? So now let's go to, this is question number 9. And let me just box them a little bit and magnify. Okay, right. So this is what the question looks like. And again, the keyword that we're going to look at will be or, because we can literally check the question, read the question first before we start working on a problem. Identify the keyword because chapter 5 is really complicated. I do not want us to draw a picture like that on the exam and look for the or. It takes so long, right? You need to look for 3 different categories without overlap, and then we add them up. Because when you add 12, 18, and 34, we do not add any common set, any common probability. So this one is pretty good. However, I just recommend people just do the work like that. So in this case, all we need to do, just look for the probability. So the change that we're running today, 50%. So the change range tomorrow, 60%. And of course, the change that is will be running for both days should be much lower than each of them. So that'd be 30%. So the probability of rain today or tomorrow, I'm going to change the marker for that. Just want to make sure that we are working on the right concept. Or tomorrow, so would be equal to probability of rain today plus the probability of rain tomorrow, and we subtract on both the and, right? So in this case, we're going to take that one is 50% plus 60% and minus 30%. And so the answers that we have, so take 50 plus 60 and minus 30%. That'll be 80%. So it's always important that we're gonna highlight a keyword because we need to know what it is, okay? Or even box them. Just wanna make sure that we all follow the keyword or. All right, so I feel like this is pretty much a pretty simple question that we might have on the exam, but it will be 8 points, or maybe 7 to 8 points on the exam by looking at a keyword. Look for 2 numbers, you add them up, and subtract the smallest. When it comes to the final exam, this question is going to be 5 points, okay? By doing just add up 2 big and subtract the smallest values. Right, so this is the easy topic. This is pretty easy topic. Now, we're going to move to something really, really challenging, I would say. It's super, super challenging because of the fact that this one going to be something that I would say a lot of people leave blank on these questions because of the fact that the conditional probability, okay? So what it means by conditional probability? So this is the topic that we do not want to see what it is, right? So let me just tell you what it is. The conditional probability is somewhat, so let's say you go to blackjack, you play the game like blackjack, 2 cards, and so one type is you don't know any number on each card. So what is the chance that your card will exceed 18 points? Versus to the fact that if you know the first card is 8, what is the chance that you can get 18 points? So this is what we have for the conditional probability. So that's really, really complicated. Conditional probability denoted by the P of A given B, okay? Of A given B. So the given is is what? The given is when you know something in advance, when we know some information in advance. So the conditional probability will be the probability will be calculate the probability if we know some information. Know some information of others. Okay. So in this case, I want to compute. I want to find. This is the probability of 8. Probability of 8. So this represent given. This is not divide. Generally, this is what it means by 8 given b. Okay, the word given, meaning that we know this is the probability of 8 if we use information on b. Okay, if we know the information of b. If we use or we know the information of b, right? So this is basically the probability. We want to compute a probability of 8 based upon the b information. Okay. So this is what it means, why it is so hard. So it's similar to the card game like that. So we have 2 cards. Generally, we don't know the number for that. We literally have no idea what the numbers are. Okay, and if I told you, because we're not going to compute a probability along the way, of course, but this is like folded, right? 2 cards are folded, so there's no way that you know information. So 2 cards are folded. So basically, the probability of compute of 18 will be different. But if I told you that the first card, you have to unfold the first one, and I got this is 8, for instance. So I know some information. I know this card will be 8. Is number 8. So it's changing a lot, right? Again, that we're not going to like doing all of that. So if we know like different scenario with different informations, then it will be changing, correct? So if we have 2 cards folded, then we don't know anything. So the probability, so this is what we call the A scenario, and this is what we call the B scenario. Okay, those are 2 different scenarios for that. So one that I know nothing, and one I know something on the card. So the probability of 2 scenario of the sum points is equal to 18. Between 2 scenarios should be different. Correct? It cannot be the same because the first scenario is when we know nothing. The second scenario is I know one card is 8, right? So this card is folded. Sorry, this card isn't folded, right? So apparently that the probability that the B scenario has the sum point equal to 18 is much higher than the first scenario because we don't know any information of that. Okay, so this is what it means by the conditional probability. So for that example, it's really, really complicated because it utilizes a lot of trick, and we have 52 cards. It's not quite easy, and to deal with that, right? So we have diamond, we have spade, we have heart, we have club. So there are 4 different types of a card, and it's not going to be something that we might see on the exam. I just want to let you know what it means by the conditional probability. Okay, so meaning that we want to figure out a certain probability based upon some information. So this is what I call conditional probability. Let's take another example that we want to know what it is. So for instance, this is the example that I have on the notes, right? So suppose that a single die is roll, and what is the probability? So we roll a single die, we roll a die, for instance, and what is the probability? What is the probability that a die comes up 5, for instance. So assuming a die has to be 6-sided die, and each number will be different, we have 1, 2, 3, 4, 5, 6, right? So what is the probability that a die comes up 5 generally? So 6-sided die, generally we have 6 different numbers. So that would be so the sample space that we have, the total outcomes will be 1, 2, 3, 4, 5, and 6, because a die have to be 6-sided. Now, all we need to do for that example is that I want to look for the probability that my die comes at 5. So 5 is one of these outcomes, right? So 5 is here, so that'll be 1/6. Do we agree? So this is something that we learned from the last lectures. I know it's still very not so clear for all of us because we did not spend a lot of time working on it. But we can literally check that we have 6 outcomes, right? So 1 to 6. So 5, one of them, so that'll be 1/6. So now let me just cheat a little bit, assuming that I cheat on a die. We cheat on a die. So we cheat on a die. And what's going on for that is, so the next row, I guarantee you, the next row will be an even numbered, odd number, odd outcome, no matter what. So I cheat them. I just, for some reason, I make some magical consequences. I make some magical turns on the die, so it's never roll on the even outcome. So it always be like an odd outcome for that. So now what's happening? What is the probability? What is the probability that a die comes up 5? So we can't literally check the difference between this 2 scenarios, right? So the first scenario is when we know nothing, okay? The second scenario is that I cheat on a die. I give you some information such that the next row will not be an even outcome. It has to be an odd outcome. So what is the probability that a die comes up 5 in this case? So a die will comes up 5. We land on 5 top of the numbers. It's different, right? So given that, so we know, so given, we have to write down a given on the second part of it. So what are we trying to find? We're trying to find a probability that a die comes up 5, given that the outcome is odd, right? So we know for sure, like 100%, that the next row has to be an odd. So what is the probability that a die will land on 5? In this case, again, the outcome is no longer 6 of them, so it's no longer like 1, 2, 3, 4, 5, 6, because we just remove all the even numbers, correct? So can somebody tell me what is the answer for that?
3.
3, right? So because if we do not count the even number, we got some information that the next row has to be an odd outcome. So the total outcome that we have is no longer 6, because the odd outcome that we have will be 3 of them. So that is 1, 3, and 5. Do we agree? So 5 is part of it. So we're going to take that will be 1/3. So this is what we call conditional probability. So some people who claim that they're really good at computing all of that, like, I'm going to change the scenario a little bit. So I bring you to casino, and let's say we play poker games, like the first 2 cards of your opponent was 3 and 5, for instance. And now we look at your card, you get, 5 and Jack, for instance. And what is the chance that we get 2 pair? It's different if we know nothing, right? So we have different scenario, different assumptions, different observation. We're going to give us different probability. So in this case, so it's the outcome is an odd number. It's no longer 1/6. It will be 1/3, right? Because we have 3 of them. So what happened if I change the question a little bit? I still give you the fact that the next outcome will be an odd. It will never be an even, but I would like to change the questions. What is the probability? what is the probability that a die lands on 2, for instance. So if we know the outcome will be an odd, if we know if the outcome is odd, will be an odd number. So this question was pretty silly, but it's actually tell us some information such that, well, what is the chance that the probability will be that what is the probability that a die will land on 2, given that the outcome is odd? It's impossible, right? Because the odd outcome again that we have will be 1, 3, and 5. This is what we have here. So 2 is not part of it. 2 is literally not part of it. So we can't not take the joint between 1, 3, and 5 and 2 because there's no common set. So the chance that a die lands on 2, if we know that the outcome, the next row will be an odd, is 0%. So that would be 0. Okay, so this is 0/3. Okay, 0/3. And that's pretty much the thing that we need to deal with. 0/3 right there. Okay. And this is 0%. So in other words, what is the how people actually set up the probability? I'm sorry, the conditional probability will be that one. Okay. Well, I mean, we need to understand. I mean, this is not the main course. The next part is going to be very difficult. Yeah, I would take that attendance for you. Okay. All right. So the probability of A given B generally, and how people actually set up the formula for that. So we can look at this example and see, right? So phi is one of them. So when the outcome is odd, when we know something in advance, that the next outcome will be an odd number. So the chance that a die lands on phi is no longer 1/6, it's 1/3, because based upon the given information, which is the probability of B. So the B in this case will be the given, right? So on the second part will be the given. So we're going to put this down. So we're going to divide it by the probability of B, right? We have to divide it by B. In this case, we divide. So the outcome will be something that we know in advance. So we have to. So there are 3 of them. So we divide it by 3. On top, what is the numerator? So we take the joint, right? So phi will be the joint between 1, 3, and 5. So the answer is 1 because this is one of them. 2, and the joint with the outcome is odd is 0%, right? Because 2 is not part of it. So when we're taking a joint between A and B, so that would be the thing that we have on the numerator. So that would be P of A and B. So that's really, really important. Okay, so this is how people establish the conditional probability. So conditional probability is something, is not just the probability by itself, but depending on the information that we get. Okay, so this is what we need to box this, okay? And you might have to see them again for the next part. So now, if I want to rewrite the formula for that, so P of A given B equal to P of A and B over P of B. Let me just rewrite them. So P of A given B, okay, will be on the exam, on the word problem, it's not going to be something like that. It will be the probability of A and B over the probability of B. Okay, over the probability of B. So, but on the word problem, they will give us the keyword and, all right? So this is really important. So what I need to do, I need to multiply both sides by the probability of B. I multiply this by probability of B and this by probability of B on both sides, okay? So when I multiply them, it doesn't really change the inequality. And then I cross them out completely. So this one is canceled out with that. So we can have the probability of the joint A and B, in this case, we'll be taking the probability of A given B times multiplied by the probability of B. Okay? So what's going on for that? How can we interpret that into something that we can easily understand? There are two ways of doing it.
Wait, you multiplied the what you did there? You
The reason
multiplied
why
the probability of B to cancel.
to cancel out this guy, and then we're going to rewrite the probability of A and B will be equal to this product, right? The P of A given B times P of B. It seems to be really complicated. Do you agree? Yes or no? So we have to
Yes.
think of it. You have to think of it. The probability of the n. I'm going to rewrite this. Okay, it's really complicated. Around 80% of my student a few years from now, like from 2014, something like that, they always make the mistake, like there's a mistake on the exam. So how can we compute a probability of the n? So we're going to take the conditional probability, and then we multiply multiplied by the given probability. Okay? Multiplied by the given probability, in other words. So we need to multiply two numbers, but the reason why this question was hard is the final exam always gives us three numbers, and then we're gonna pick two to multiply. Okay, and most of my students are out of luck. If you pick the wrong numbers, you're gonna get the wrong answer. So that's really, really important. So we're gonna pick the conditional probability, and then we multiply by the given. So this is the thing that we need to do. Conditional probability and multiply by the given. How do you know if that particular topic is conditional probability? So this one is usually like a long sentence, right? Long sentence include two clues, two different clues for that. Two different information, two different info. So it looks really complicated using this method, and sometimes we don't know what it is. Followed by the keyword like given, and if of those, whatever it is, or yeah, who, whatever. So the given will be right after the keywords, right after the keyword given, if, of, and who. Okay. So this is after the keyword, after if, given, if, so on and so forth. Okay, but how do you know which one will be the given and which one will be the conditional probability? Then that will be a different story. So now we're going to deal with the questions with the keyword and. Again, this one is really complicated. Let's try them out and see how it goes. Okay, I'm going to try questions number 4 on the sheet and see what it is. So I'm going to copy and paste. Okay, let me just go back to that. Copy and paste for these questions. Okay. And let's see. Yeah, this is what the question looks like. I think I would do question number 1 first. Okay, so this is what it has. Usually, like the kids who have suffer the eczema, they have food allergy. Okay, usually, but it's not like 100%. So my son has eczema, but he also has the seafood allergy as well. So according to the U.S. News, 30% of the U.S. infants suffer eczema, and 50% have food allergy. And of those who suffer eczema, so 70% will have the food allergy. And we want to find a probability that a random selected infant has food allergy and suffer eczema. So whenever you see the keyword and, then we're going to highlight this. So this is going to be something that we need to multiply two numbers, okay? But the questions give us three of them. Okay, let me just highlight them. So the question will be three probabilities. So one will be 30%. The probability of the eczema is 30%. Okay. And so that will be 30%. And then the probability of food allergy will be 15%. So one of them will be something that we need to get rid of. Why? We going to look at the keyword of those, so we can see the keyword of those who suffered the eczema, and 70% have the food allergy. Okay, so we're going to highlight them of those who got eczema. So we only look at the people who got the eczema. So this is the given. Okay, and 70% have food allergy. Right? So how can we understand this sentence? So this has include two different types of information. I'm going to highlight them. So for the entire sentence, this 70% contain allergy and eczema. So this one has two different types. So 70% will be something that we cannot get rid of. So this will be the conditional probability. So I want to highlight that. This will be the conditional probability. Okay, because that's include two different types of the information, two different info, eczema and food allergy. So each of them is eczema and allergy. So what is that 70%? This 70% will be the allergy, will be the probability of allergy, right? Given those people who suffer from the eczema. So this 70% will also be the allergy. So meaning that when we look for the probability of allergy and eczema. So I'm going to change the marker a little bit. Just want to make sure that this one is important for the keyword. So this one will be equal to what? This will be, we're taking the conditional probability. So that would be 70%. When we have 70%, then we need to convert them into decimal number, because this is multiplication. So we're going to take 70 over 100. We're going to get 0.7. Okay, so that's really important. Again, how can we convert to percentage? We go, from percentage to decimal number. We're going to take that and then we divide it by 100. Similarly, we take 30%, we divide it by 100. We're going to have like 0.3. Okay, and then next we're going to take 50%, we divide it by 100, so that'll be 0.15. So which number should we get rid of? So this is the easiest step that we need to look for. First, we cannot multiply the same thing together, okay? But we need to take 0.7 for sure, like 100%, because this is a conditional probability. It has two different types of information. We multiply what? We can't multiply two food allergy together. So this is 50% also food allergy, and 70% also food allergy. But remember, we cannot get rid of 70% because this is conditional probability. So we cannot multiply two food allergies together. So this one have to be killed.
Wait, why you put on the percentage 70%, 30%, and 15%? Why you did that? Why you put 0.7, 0.3?
Because when you multiply percentages, we need to convert to a decimal number. Okay. So again, that we need to, when you add them up, it doesn't matter, or subtract. We can keep the percentage. However, when you multiply two of them, then we need to convert to a decimal number. Okay. So instead of we keep 70%, we're going to rewrite them as 0.7. So again, that we cannot multiply two food allergies together, meaning that we're going to take 70% times 30%, right? Because 30%, this is the given. This will be the given, right? This is the given. Okay. In other words, we cannot multiply the two same things. So 70% will be the allergy from the people who suffer from eczema, and but this 15% will be the allergy for all the people, for all people regard regarding the eczema or the other things. But generally, 50% will be the more general food allergy. The 70% will be the food allergy from the eczema people. So this is what we have right there. And then we're going to take 0.7 times 0.15, I would say 0.3, and you're going to get the final answers correctly. Okay, so we're going to do the math. We're going to take 0.7 times 0.3, and we get 0.21, which is 21%. Okay, so that's pretty much a thing. If we do 70%, we multiply by 30%, for instance. Well, what do we get? We're going to get 2100. That's basically not going to help us a lot, right? So the first step, when we see the keyword and, we need to convert all of those in decimal numbers, and then we're going to pick 2 to multiply and get rid of 1. So this is the hardest part. The reason why this one is hard, because we don't know, sometimes we don't know which part that we should get rid of. Okay. Let's try question number 4, and then I will let you go. This part we're going to go over it next.
Wait, can you go back real quick, please?
Which part? This note is on Blackboard. I'm gonna show you how we're gonna look through it and see what the difference are. Okay, so let's take a look at question number 4. All of these note is on Blackboard. All right, question number 4 right there. Okay, so let me just do this part real quick. Okay, so this is the thing. This is what the question is, and the keyword that we're going to have will be "and." Okay, so whenever you come to the keyword "and," the probably the senior and biotech majors. So what should we do? We need to multiply 2 numbers, right? We need to take 2 numbers to multiply. So first of all, we're going to highlight this. Of those major in biotech, 60% are senior. So we're going to write them down. Of those major in biotech, 60% are senior. So this is really, really important. So the reason why this one is really important, because that 60% is the conditional probability. Why this one is the conditional probability? Because it's include 2 different types of informations, right? So let me just do that again. So the reason why this one is really important, because that's conditional probability. How do I know that? So I read the sentence, I know the keyword of those, and I also have the keyword right there, biotech and senior. So that includes 2 different types of information. So that have to be the conditional probability, and this one will be the longest sentence. Okay, so we cannot get rid of 60% for sure. We always have to take that to multiply with one of these numbers, and so this one will be 0.6. Okay, we take 60%, we convert to the percentage, so that would be equal to 0.6. Are we good? And after that, we're going to read the questions. The probability of senior is 50%. Okay, so which is 0.5. And then the probability of the biotech majors would be 65%. So in this case, so that would be 0.65. So what should we get rid of? So this one is 60% of a senior, right? So this will be 60% of senior. So we can really check that 60% of a senior. So we can read from this line or from that line, doesn't matter. So this is also the senior probability, but coming from the biotech majors, right? So meaning that we cannot multiply 2 seniors together. So one of them need to get assassinated, which is that one, right? So we need to get rid of senior because we can't multiply 60% of senior times 50% of senior, right? So in other words, we're going to take 60% times 0.65, and we're going to get the final answers correctly. Okay. And then we're going to do it on a calculator. So the whole part of it, like if the questions only give us 2 numbers, that should be very easy. But the question's going to give us 3 different numbers, so we need to get rid of 1, and then we multiply another number for that. So the answer for that is 0.39, which is around 39%. All right, so far so good. And I'm gonna go over this part tomorrow. So remember, tomorrow will be the Wednesday, basically a normal schedule. We're gonna see each other again on that date, and then we're gonna go over this topic again because this one is really, really complicated. So I feel like it's too much for today. Let's take attendance, and then I will let you go. Right. So again, how do you know like which one is conditional probability and which one will be the given? For me, it's really, really easy. This is the method that my students show me. If we have 2 senior, get rid of 1 with the least information. That's it. If we have the 2 same conditional probability, like food allergy, so 1 have to be killed, which is the food allergy without any condition. So I'm going to take attendance, and you can just leave Zoom after the class. So Shayla is here.
I'm here.
Very good. And Venice.
Yeah, I'm here.
Very good. Permandai. Okay. The classwork number 5 due next Monday.
You know who's asking, Professor? Melinda Simmons?
I can't hear you, so your voices are breaking. The chapter 5 summary is basically on Blackboard, and yeah, this is really important. Permanda is not here. Wiener.
Here.
Very good. And Ulis is here. Afraid. Afraid is here.
Professor?
Yeah.
You marked me absent.
What's your names?
Melinda Simmons.
Oh, Permander.
Yeah, Melinda,
Okay, I can't. No, we haven't. I didn't really mark you absent for that. This is Permander.
No, that's not me. Simmons. Simmons.
Okay. All right, so I got you. Melinda, right? And Afraser? Okay, so not here. Diego's here. Diego's here. Let me just look for the names for that real quick. So not he. Jose's. Jose's here. So it's not here. Adammer is here.
Yeah.
Very good. Yes, Billy. Yes, Billy is here. Okay. Eric is here. And let's.
Yes, I'm here.
Yeah, absolutely. So now we're gonna go to Ollie is here.
Here.
Yeah, Emily. Emily is not he actually. Okay, so Katrina is here. Edu is here, and Virgin is here. Barry's near Barry. Okay, and so we called him
Here.
very good. Oh, Joe's
Here.
Kimberly's here, and Janik.
Here.
Okay, Stephen. So again, for the first quiz, we can't. You're allowed to make up the first quiz, but not the second quiz. So for those of you who missed the first quiz, just email me, and then you should be allowed to do it again, but only for this.
Did you post the second quiz?
No, I haven't. Second quiz will be next Monday.
Okay.
Selena is here. Jason's
Present.
present. Fantastic. Roberto's
Here.
Amber is here. Melinda is here. And Jadali's not here. Brian's is here. And Oliver
Here.
is
Here,
fantastic.
here, here.
All right, so I got you. All right, so you guys going to have a great day. We're gonna see each other again next tomorrow. Okay, so at 2 p.m. as well. So take care.
Is there anything done?
Actually, not really, because we haven't really gone through like all of the concept. We finish it, but we still have to go over a few questions before we can start work on the classwork. I want to make sure that we understand completely this topic before we move on to the next one. Take care.